So now let's talk about image file execution options. So image file execution options provide you with a sort of mechanism to make debugging an executable much easier. This is extremely useful if you have some problems with your code, and especially with a program's startup code, and specifically if you are trying to debug services. Okay, so Microsoft provided that kind of option built into Windows. Now, from our perspective, this Windows debugging feature can be used for persistence. Okay, and there are three interesting options we will cover in this video. The first one is Debugger, the second one is SilentProcessExit, and the third one is Verifier DLLs. So the Debugger option allows you to start your application you are investigating under the control of the debugger, like by default. Okay. The second option, which is SilentProcessExit, does something opposite, which is allows you to monitor the what is happening at the end of the process, like when the process exits. Okay. And the third option, Verifier DLLs, is related to Application Verifier, which is pretty old tool created by Microsoft. It was some sort of verification tool for testing applications for compatibility with Windows XP. So it's, I don't know, it's 15 years old or even more. But what is interesting in Verifier DLLs and Application Verifier is that it allows you to hook specific functions from a specified DLLs. Okay, so you can create a Verifier DLL, and it will get injected into your process of your interest, and actually you can hook specific functions with that. But we will cover that later. Now let's take a look at where these all settings live. So as usual, settings for image file execution options live in registry. So we go to Software, Microsoft, Windows, NT, current version, and we scroll down to image file execution options. So under that key, you if you want to specify some options for the specific application, you just create a subkey with the name of your binary, and in that key you can set all debugging options you need. So let's do that for the debugger. Okay, and we will be targeting BGInfo again, which is a 32-bit process. So we have to take into account that fact. So let's start. Actually, let's start. Let's start it with 32-bit command line. And we will need elevated shell as well. So let's go to RTO persistence. So for the first option, if we want to use a debugger option for our persistence, you just need to create one value in the registry. So let me copy this. So what we are doing is under that key, image file execution options, we create subkey of the name of our target binary. Okay, and the value is debugger, which will hold a path to our implant, okay? And I'm specifying that it's going to go to registry responsible for 32-bit applications or processes. If you want to do it for the 64-bit, you will set it up like that. But as we are targeting BGInfo, which is 32-bit app, we need to use this setting. And we can actually verify if it all looks good. So query. Okay. And that's it, actually. So let's simulate how it works. Let's first start Process Hacker, as we want to see what is happening. And let's open up BGInfo. And as you can see, Notepad has started. So, and you don't see the BGInfo started, right? And the reason is very simple, because this mechanism works like that. When the new process creation is requested, system loader will check if there is any setting for the debugger in this registry key, and if so, it will start that any application which is specified under debugger value, and it will actually pass the info about bginfo.exe as the input application for the debugger. So in other words, bginfo is started under the control of the debugger, which is in our case is implant, although we know that it's not a debugger, it's just our implant. But in normal usage, this value would point to a real debugger, okay? So like OLEDBG or immunity debugger, etc. Because our implant is not a debugger, then BGInfo is not started, okay? So you have to keep in mind that if you use that setting for persistence, you will need either to implement your implant as the debugger, or you just pick an application which is not like crucial or critical for the system, and it will get unnoticed if something breaks. So that was debugger option. Okay, so let's clean it up because we don't want to leave any residue. The second option I told you about was SilentProcessExit, and setting this requires a little more effort. So as I told you, this works like the following. When the application starts, okay, and it's running, and after it has completed, it will call the exit process function call, okay? And if we have the setting for the silent process exit in our registry, then Windows operating system will launch our process monitor at the end. Okay, so let's set it up. So we need to set up three. Well, let me do this like that. So we have to set up again a BGInfo key with a global flag, value global flag set to 520 and 512. Okay, and again we are targeting 32-bit application, so keep in mind to set it for a registry, 32-bit registry. The second option we need to set up is another subkey under SilentProcessExit key, okay, with the value monitor process which will point out to an application doing the monitoring. In our case, it's our implant. And finally, we have to enable that reporting mode set to 1. And again, that's it. So let's try to run bginfo. So now it runs. Okay. Since bginfo is has some timeout set, so after it exits, our implant has started. So to recap, this application is running at the end of the life of the specified process. Okay, and we are here. So let's clean up. So that was the second option for persistence. So let's clean up first before we move on to this third one. And a third option is called Verifier DLLs. So as I said, it's related to application verifier, which is really old tool. And it allows you to load your DLL, which is loaded at the process creation time to verify specific, whatever you need to verify at the process startup. And this option can also be used for persistence. So to set it up, it's really simple. You specify just one thing, verifier DLL, and with the name of the DLL. But there are two things you have to remember. So your verifier DLL or implant DLL has to be copied to the either System32 folder or syswal64 folder for the 32-bit applications. That's one thing. And the second thing is you need a special type of sort of DLL. It's not a regular DLL. And let me show you how this DLL looks like. So we go to admin and verifier. Okay. We have a verifier here. You can compile it. And let's open this up. So we go to audio, pers, admin, verifier, and let me walk you through the source code. So it's a DLL, so it holds the DLL main, okay. But there is an additional reason which of the DLL loading, which is DLL process verifier, and on that event we run process verifier function, which actually sets one specific structure in the memory of the process. And after that, we actually run our code as a thread. So our function go, which will launch our implant. Okay. And this is something you should be aware of, that you just cannot run go from directly. It has to be run as a separate thread, as this function should return as soon as possible. Okay. And so if you want to use that technique and use something different, then just edit this go function and you should be good to go. And the rest is pretty straightforward, since we need to have several structures, definitions, which then are used by the verifier. Okay, So that's the code. So we have compiled that. Now we need to copy VRF to Windows syswow 64, as this is the application 32-bit application. Okay. And let me actually verify if the setting is done correctly. Query query. So we have that for, we are missing one setting. So we've set the value for verified DLLs, but we also have to set global flag to 256, and now we should be good. Okay, so let's go to bginfo and let's run it. So Notepad has started, bginfo is running. Let's suspend it, and our verifier DLL is here. Okay, so it actually started our process, our implant, and so the way it works is that when the system loader creates a new process, it will verify this value, this verifier DLL values. Sorry, these values. Okay, and if it exists, it will load a verifier DLL into the process, which will then load all that DLL loads actually all the verifier DLLs into the process. Okay, so this is how it works. So yeah, that's the third way you can use image file execution options for persistence. So let me clean up. So the only thing we need to do is we need to remove that, and now hopefully bginfo will run without any problems. Okay, so that was image file execution options as persistence.